of a chemical reaction. Consider the following reaction, where in a certain industrial operation, 3.54 times 10 to the 7 grams of titanium 4 chloride are reacted with 1.13 times 10 to the 7 grams of magnesium. Calculate the theoretical yield of titanium in grams. Then calculate the percent yield if 7.91 times 10 to the 6 grams of titanium are actually obtained. This is clearly a limiting reagent practice problem. However, before determining the limiting reagent or performing any stoichiometric calculations, we must first write a balanced equation. The balanced equation for the process will be titanium 4 chloride plus magnesium yields magnesium chloride and titanium metal. Of course, we must balance the equation where on the left side we place a 2 in front of Mg. On the right side we place a 2 in front of MgCl2. This will balance the equation yielding a molar ratio of 1, 2, 2, 1. If the reaction occurs between 950 degrees C and 1150 degrees C, then the titanium 4 chloride will be in the vapor state. The magnesium will be molten, as will the magnesium chloride. However, titanium has a melting point of 1,668 degrees Celsius, so the titanium will be in the solid state. Now that we have a balanced equation and a molar ratio, we may begin our calculations, where in the information we were given 3.54 times 10 to the 7 grams of titanium 4 chloride and 1.13 times 10 to the 7 grams of magnesium. Additionally, we were given 7.91 times 10 to the 6 grams of titanium that was obtained as a product. So, the first step is to determine the limiting reagent, since we're given information about both reactants. To do so, we must first calculate moles, where moles of titanium 4 chloride is equal to the given mass, which was 3.54 times 10 to the 7 grams, divided by the molar mass of titanium 4 chloride, which is 189.7 grams per mole. This will equal 1.87 times 10 to the 7 mole of titanium 4 chloride. For the magnesium, we divide the given mass, 1.13 times 10 to the 7 grams, by the mass of magnesium, which is 24.3 grams per mole, which will yield 4.65 times 10 to the 5 moles. Now that we've calculated the number of moles available for each reactant, it is possible to determine which reactant is indeed the limiting reagent. To do so, we must refer back to the molar ratio, where the molar ratio between titanium 4 chloride and magnesium is 1 to 2, which means that for every 1 mole of titanium 4 chloride consumed, 2 moles of magnesium are required. From the calculations, we know that 1.87 times 10 to the 5 mole of titanium 4 chloride is available, and 4.65 times 10 to the 5 mole of magnesium is available. However, do these mole values match the molar ratio? I think it's obvious that they do not. However, let's confirm this. Let's begin by determining the amount of magnesium required to consume the 1.87 times 10 to the 5 mole of TiCl4. To do so, we multiply 1.87 times 10 to the 5 mole times the fraction created from the molar ratio, where according to the molar ratio, 2 moles of magnesium are required for every 1 mole of TiCl4. So we write the following: 2 moles of magnesium divided by 1 mole of TiCl4. Obviously, the moles of TiCl4 will cancel, which leaves us with moles of magnesium, which is good. Now multiplying the 1.87 times 10 to the 5 by 2 will equal the following. So the amount of magnesium required to consume the titanium 4 chloride will be 3.74 times 10 to the 5 mole. However, how much magnesium do we have on hand? Well, on hand we have 4.65 times 10 to the 5 mole of magnesium. Only 3.74 times 10 to the 5 mole is required. So clearly the magnesium is in excess, and so we do not use the magnesium in any further calculations. Since the magnesium determine how much TiCl4 is required to consume the 4.65 times 10 to the 5 mole of magnesium. Well, to do so, we multiply 4.65 times 10 to the 5 moles of magnesium times a fraction, 1 over 2, where now the 1 is in the numerator and the 2 is in the denominator. This will actually allow us to cancel the moles of magnesium, since here the moles of magnesium is in the numerator and here it is in the denominator. Multiplying 4.65 times 10 to the 5 times 1 over half is equal to 2.33 times 10 to the 5 moles of TiCl4. And since we were only given 1.87 times 10 to the 5 mole of the compound, clearly the titanium 4 chloride is limiting, since it cannot consume all the magnesium. Now that the limiting reagent has been determined, it is possible to calculate the amounts of each product formed. To do so, we first return to the molar ratio, where the molar ratio is 1 to 2 to 1, where we exclude the excess reagent. The ratio between TiCl4 and MgCl4 is 1 to 2, and the ratio between TiCl4 and Ti is 1 to 1. Let's determine the amount of Ti formed first. To do so, we multiply the amount of the limiting reagent, which is 1.87 times 10 to the 5 mole, by a fraction that's created from the molar ratio. This fraction will actually be 1 over 1. However, the convenience of this fraction is that it will allow us to cancel the moles of TiCl4. This leaves us with moles of Ti. So obviously multiplying 1.87 times 10 to the 5 by 1 will equal 1.87 times 10 to the 5 mole of Ti formed. In the case of magnesium chloride, we perform a similar process where 1.87 times 10 to the 5 mole of TiCl4 now times 2 moles of MgCl divided by 1 mole of TiCl4. Once again, the moles of TiCl4 will cancel, and we're left with moles of MgCl2. So multiplying 1.87 times 10 to the 5 times 2 mole of MgCl2 will equal 3.74 times 10 to the 5 mole of magnesium chloride. So during the process, we will form 1.87 times 10 to the 5 mole of Ti and 3.75 times 10 to the 5 mole of the magnesium chloride. Now let's determine the mass of each product formed based on the limiting reagent. It was determined that, based on the limiting reagent, 3.74 times 10 to the 5 mole of magnesium chloride should be formed, and 1.87 times 10 to the 5 mole of Ti should be formed. To determine the mass of each of the products, we multiply the moles times the molar mass. So multiplying 3.74 times 10 to the 5 mole of MgCl2 times this molar mass, which is 95.3 grams per mole, will equal 3.56 times 10 to the 7 grams of magnesium chloride. And of course, to determine the amount of Ti formed, we perform the same procedure. We multiply 1.87 times 10 to the 5 mole of Ti times this molar mass, which is 47.88 grams per mole. This will equal 8.95 times 10 to the 6 grams of Ti. Both the mass of magnesium chloride and the mass of titanium represent the theoretical yield. In other words, the theoretical yield is based on the stoichiometry from the balanced equation. Recall from the practice problem that we were asked to determine the percent yield of titanium. and we calculated that the actual yield, which was generated from a balanced equation, is actually 8.95 times 10 to the 6 grams. In the information, we were given that based on an actual experiment, the actual yield was found to be, for that particular experiment, 7.91 times 10 to the 6 grams of titanium. To determine the percent yield, we simply divide 7.91 times 10 to the 6 grams of Ti by the theoretical yield, 8.95 times 10 to the 6 grams of titanium, and then we multiply by 100. So the percent yield, based on the information given in the practice problem, for this particular reaction will be 88.6%. Had we been given an actual yield of magnesium chloride, then the percent yield could have been determined by using the same technique.